The garbage collection subsystem operates on a generational model with 3 distinct heap regions: the young generation, the old generation, and the permanent generation. Objects are allocated initially in the young generation, where most are reclaimed within a single collection cycle. The young generation uses a copy-on-collection algorithm, moving surviving objects into the old generation after a configurable threshold of collection events. This arrangement minimizes pause time for the majority of collections. The young generation heap is subdivided into an Eden space and 2 survivor spaces, designated S0 and S1. New object allocations occur in Eden space until a minor collection is triggered, which occurs when Eden reaches a specified capacity threshold measured in megabytes. The default threshold is 32 MB, though this value may be adjusted via the Roman 20:new size parameter. During a minor collection, all reachable objects in Eden are scanned and moved to the active survivor space. Objects that survive a configurable number of collection cycles are promoted to the old generation. The promotion threshold is specified by the Roman 20:max tenuring threshold parameter, with a default value of 15 collection events. This threshold can be reduced to accelerate promotion if young generation collections are occurring too frequently, or increased if old generation pressure is high. Adaptive sizing may override the static threshold based on observed survivor space utilization. The old generation employs a mark sweep compact algorithm. When the old generation heap reaches a specified occupancy percentage, a full collection cycle is initiated. This percentage is configurable via the Roman 20:CMS initiating occupancy fraction parameter with a default of 70%. Full collections require scanning all objects in both young and old generations to determine reachability, resulting in longer pause times. The pause duration correlates directly with heap size and object count. Concurrent marking may be enabled to reduce full collection pause times by performing mark operations during application execution. The Roman 20:+ use conc mark sweep GC flag activates concurrent mode, which performs mark operations in background threads, while the application continues execution. The compact phase still requires a stop-the-world pause. Concurrent marking incurs additional CPU overhead and may not improve total throughput for applications with low allocation rates or heap sizes under 1 GB. Heap fragmentation occurs after collection cycles when reclaimable regions are scattered throughout the old generation. The compact phase reorganizes objects to eliminate fragmentation and create a contiguous free region. Compaction improves allocation performance by reducing the number of probes required to locate sufficient contiguous free space. However, compaction incurs measurable overhead and is typically performed selectively during full collections rather than after each minor collection. The Roman 20:+ use G1GC flag enables the garbage first collector, which divides the heap into fixed size regions and prioritizes collection of regions with the most reclaimable space. This approach provides more predictable pause times and scales to larger heap sizes. Regions are collected in phases. Initial marking identifies root objects, concurrent marking traces object graphs, and final marking completes the tracing. Young regions are always included in collection sets regardless of reclamation potential. Pause time targets may be specified for G1GC using the Roman 20:max GC pause millis parameter with a default of 200 milliseconds. The collector attempts to meet this target by selecting collection sets that can be processed within the time limit. If the target cannot be consistently met, the pause time threshold is relaxed automatically. Very aggressive targets, below 50 milliseconds, may result in more frequent collections and reduced throughput. Conservative targets above 1000 milliseconds may not reflect actual pause time behavior. Mixed collections occur when young and old regions are collected together. The G1GC collector initiates mixed collections after concurrent marking completes, selecting a collection set containing young regions and a subset of old regions with high reclamation potential. Mixed collections continue until the percentage of reclaimable space in candidate old regions drops below 5%, at which point collection focuses on young regions exclusively. This adaptive approach balances pause time and throughput. Humongous object allocation occurs when an object requires space larger than half a region size. These objects are allocated directly into old generation regions and are collected only during full collections or concurrent collections that include old generation space. The Roman 20:G1 heap region size parameter controls region size, with values ranging from 1 MB to 32 MB. Larger regions reduce the frequency of humongous allocations, but increase the time required per collection event. Card marking optimizations reduce the cost of scanning old generation objects for references to young generation objects. Young regions are protected by write barriers that track cross-generational references at the granularity of a card, typically 512 bytes. When a young collection occurs, only cards containing outbound references to old generation objects need to be scanned. This approach scales better than scanning entire old generation regions for young generation references. The Roman 20:+ parallel GC threads parameter controls the number of threads used for parallel collection phases. The default value is derived from the number of logical processors available to the runtime, typically set to 1/8 of the processor count on systems with more than 8 processors. Increasing thread count may reduce pause time but consumes additional CPU resources. On systems with more than 32 processors, parallel collection threads may contend for synchronization primitives, reducing effective parallelism. Survivor space sizing affects promotion behavior and collection frequency. The Roman 20:survivor ratio parameter specifies the ratio of Eden space to survivor space. The default ratio of 8 means one survivor space occupies 1/9 of the young generation, with Eden occupying 8/9. During collection, surviving objects must fit in the inactive survivor space or be promoted. If survivors exceed survivor space capacity, they are immediately promoted regardless of age. Ergonomics mode enables automatic heap size and garbage collection policy selection based on application, characteristics, and system resources. With ergonomics enabled, the collector selects appropriate defaults for young generation size, old generation size, and collection algorithm. The Roman 20:use adaptive size policy flag disables ergonomics, allowing all sizing parameters to be set explicitly. For production deployments requiring predictable behavior, explicit configuration is recommended over ergonomic defaults. Heap occupancy statistics are reported through the logging subsystem. The GC log file size and number of GC log files parameters enable automatic rotation of collection logs, preserving historical data for analysis. Each log entry includes collection phase, pause duration in milliseconds, heap occupancy before and after collection, and user time consumed. Real-time monitoring of collection frequency and pause distribution provides data for tuning decisions. Collections occurring more frequently than once per minute indicate inadequate heap size. Emergency full collections are initiated when allocation requests cannot be satisfied from available free heap space. These unscheduled collections may occur during young generation collection if objects cannot be promoted due to insufficient old generation space, or during old generation allocation if the old generation is full. Emergency collections often exhibit pause times significantly longer than routine collections. Persistent emergency collections indicate heap size configuration inadequate for application workload and memory retention patterns.